Hello folks, so in this video I'm trying to solve LeetCode problem 1920, 1920 build array from permutation. So this is given a zero-based permutation of numbers basically. I think it's a permutation of numbers where the order of the numbers is different. Build an array ANS, I think it's short for answer, I don't know, of the same length where ANS of I is equal to nums of I. So nums is the initial array, input array, and for each I nums dot length. So zero-based permutation nums is an array of distinct integers from 0 to nums dot length minus 1 inclusive. Right. So for example, this is of size 6. So 6 minus 1 5. So 0 to 5 will have all the numbers in a different permutation. Right? If it's 0, 1, 2, 3, 4, 5, that is 1. This is also 1. Right. And the interesting thing they say is over here, can you solve it without using extra space? Initially, you can just solve it using some space, I think. For example, I can just already write ahead and say, you know, n is colon equal to, um, array of integers, and then say 0, comma, and then, or I can actually put the full size nums dot length, and that's not it's then of nums. That's the, and you can then actually find out type using type and all that. But I don't need type, I'm just going to use a len function. Uh, and yeah, so now I can just say, for um, I colon equal to 0 and I less than then of nums I plus plus and then ans of I. So I actually created an array which has zeros initially because it's an integer, so you have zeros. The default value, the zero value, um, and the maximum length capacity that it can have is this, though it can grow, but initially it's getting some extra space. So if it has 100, I think the maximum size is 1000, so it will have 1000 integers. So it is equal to nums of I, and you can return ans, and you can actually try to run this to run the test case and see if it works. Looks like it works, right? So it didn't take much time, but it will take some amount of. It's a pretty easy question. It clearly says it's an easy question. Can you solve it without extra space? Is the question. So, so yes. Now you can actually see that it took up 8.66 MB, so it took up 0 times. So and there are people who have actually gotten it done in less memory, right? I got it done in 8.6 memory, but this was 7.9. Not much memory being used, but I think if you run it again accordingly, some memory will be used. So I think if a garbage collected language happens to be there, I wonder how it works. Let's see if we can use Rust. And okay, it says vector. Interesting. I think vector is on the heap. I'm not sure. Anyways, for now, I'll just go with Go itself. So, yeah. And I'm going to actually think about how we can actually do this without using extra space, right, in O of 1 memory, because we are currently doing O of 2, I think. Uh, we are using twice the length of memory instead of just one, the input memory, right? Now, they want us to basically go ahead and manipulate nums itself, I think, and return it. That will become a mutable thing, but I think that's what they want. They want to mutate it so that they use less space. So it's in functional programming you would do this only, but in non-functional I mean in functional you don't mutate a variable or even an array, I believe. You just create new variables, new stuff out of it. In this case, It's an array, you create a new array out of it functionally. But they want us to actually mutate it and change the input array itself. I'm wondering how this would happen because if you keep mutating the input array and start putting the output in the input array itself, then won't you lose the input data? So that's where I was starting to think about how this whole thing works. And let me try that. Start up thing terminal and let me go to LeetCode and just this is an old problem that I had. Again, minimum domino rotations or equal row problem. And now I can actually go to problems and actually create this 1920 build array from permutation. Build array from permutation and this uh, go mod image, remove this, and this as I'm going to use Golang, and this opens up, right? And here I will actually copy paste the code, I mean the session, right? Oops, this, um, let's put it in the README for now because that's how it works. Let me see if I've done something similar before. And problems. How have I done it? So readme.dm. It's MD that I choose. Right. So put this. And, this is design. This is a good problem. Very easy though. Um, easy. So let's actually do this where layers of values for each 0 to numbers.name and return it. Then is that a zero-based rotation numbers is an array of integers from 0 to this. Okay. And you have to create this. 0 to nums length 1. That's inclusive. And this is the example, an explanation, and another example, explanation. And constraints, there are three constraints. Actually, for follow-up elements and nouns are distinct, and this is complicated code. So, yeah. So now I'm starting to think, let's take this example and try to understand how we can actually create the final output of this example, right? And I'm going to close this up, and this is the final thing that we need, right? Um, how do we get this? By just changing this input, right? Expected output is this. So this follows as paper one and so mutate input, right? Now is of I is equal to nums of I. Now what we're doing here is we only read nums of I here, So that is fine. We need nums of I um, to read, um, right? And we also need nums of I to read, right? And what are we writing? We're writing to nums of I, right? So we are going to lose nums of I if we actually write to nums of I. I mean, assuming A and S is equal to nums, right? Because it's the same thing. So we're going to write to. So if basically A and S is equal to nums, then we just say nums of I equal to nums of I. Now what we lose here is if someone else reads this nums of I, it's going to be a problem, right? For example, but will you need it is the question, right? For example, if I is equal to 0, I equal to 0, um, you take nums of 0, right, is equal to nums of 0. You need nums of 0, right? You will read it. This will happen only later, right? So you will need nums of 0, and then you will need nums of 0, and then you will write to nums of 0, right? So does anyone else require nums of 0 is the question, right? I mean, if you think about it, when you're writing to nums of 0, does anyone else require nums of 0? Maybe not. Or is that false? Is the question. So let's think about it. Write nums of 0, and you lose it, right? Let's say this is some x, this is some y, and you lose x, right? And nums of 0 finally becomes y, right? So, and you understand from this that nums of x is y, right? So, finally, now what you understand is hmm, if this is x and this is y, that is nums of x is y, and you're changing nums of 0 to y now, and you lose nums of 0 now. And, you lose nums of 0, you lose your x, right? And does anyone want nums of 0 after this? Let's see. They'll need it. They'll need nums of 0 is needed, that is x, right? X is needed when nums of anything, let's say j, is equal to 0. Because then, if something points to 0, right, then let's say then you will have nums of j equal to nums of j, like this is what you will need k, and where nums of k equal to j, right, is needed when this is this nums of j is 0. For example, for a k, nums of k equal to nums of k, and where nums of k is equal to j, right? So then you will have nums of k equal to nums of j, um, what nums of j? It's more like nums of k And hmm, wait a minute, I got confused. I think so. You need this x value if something, when this is 0, right? Um, and you'll end up with nums of 0. It's like then it will be like you'll be looking at not nums of k is not 0, more like. So then you'll actually need, no, this is wrong. This means you basically say when nums of k equal to 0, basically j and k are equal. J and k are equal. In this case, it's 0 basically. J equal to k equal to 0. And in our case, interestingly, it is that, right? So for I equal to 0, if you get a value, hmm, let's look at it more mathematically. So if there is an I, so we say nums of I equal to nums of I. So we can first read nums of I, and this will give an x, let's say, and this will give a nums of x, and this will give a y, right? Right? Y to nums of I, right? So, and you lose x. You lose the value x. So, who else will require x? Right? Who else will require nums of I? Who requires nums of value x? Value, whole value x, right? It'll be someone who has nums of k equal to nums of k. Will require the value x when it is, will require the value x when uh, nums of k is I, right? When it is equal to I, and hence nums of nums of k is nums of k is I, so this, then you will require x, right? And then you need to say nums of k is x is equal to, right, x to nums of k. right? Now, now we need to see who and all has nums of k as I. Remember that I is one value between say 0 and len minus 1, and I is between greater than or equal to 0, and also same is true for nums of I. And every I is distinct, and every nums of I is distinct, right? With this in mind, if there is an I where nums of k is equal to I, it's like a pair now. So only this will have I. No one else will have anything as I. Only nums of k will have I, right? Hmm. Let's look at the actual values. Let's say there is I, there is k, right? This is the whole array, different values. Doesn't matter what these values are. And remember that even so you need actually num of I is initially x. So you need this x here, right? And num of k is basically if num of k is I, then num of I is x. You can't have x here also. This is not possible, right? Because once you have an x, we actually write y. So we write y to this. We need x only here. Okay. So you basically try to find out this is a unique value. No one else will have x value, right? So you just store that nums of I is x. You write to this, right? And whenever you find a num of k equal to I, this is the index actually. This is the index. Values is gonna be x, num of k is I, right? So here we are just saying then I is less than k, right? And hence x is less than I. Okay, assuming num of nums of k is equal to I, right? Um, nums of k is equal to I. Nums of I equal to x, right? This is the input. Output will be index and values. Hmm. It means I is less than k, and k are not equal. And if before I comes before k, I comes first, k comes later. Okay? And you're losing I, and you will need it later. Like you are losing nums of I, and you will need it later. You are saying you will need it later, right? Assuming you need it later is then if you're losing it, it's a problem, right? So if you're not gonna need it later, then it's okay. You lose it. It's fine. You just needed it now, and you don't need it later, so it's fine. Only for this case, we're gonna look at it because we are gonna keep overwriting from the left to right, right? Or right, left, whatever you want to look at. So for now, we're just traversing from right to left, traversing from left to right. Okay. So assuming traversing, so if that is the case, then so this is input, this is output. So we're saying the output is going to be this. We need x later. If we override this with y, we lose it. So what is y? Nums of x is y. What is y? Nums of x is y. Hmm. And what is nums of y? No idea. Hmm. Nums of x. So these are also, we're saying x is less than I, right? So we're saying x is less than k, right? If x is less than I and I is less than k, so x is less than k. These are all values by the way. So and you're also saying y is less than x means I is less than k, x is less than I, and actually x doesn't have to be less than I. Index only is the thing. So I is less than k, and okay, so these values can be in any order. We're just looking at the indexes. I is less than k, that's all, right? So, hmm, I is less than k. We have nums of x. Nums of x is y. No, is there any connection between x and I? Hmm. So we say nums of I is x and nums of x is y. Can we say anything about x and y? No, not really. We can just say that they're part of the numbers, that's all. Hmm. Assuming nums of I is x, nums of k is I, right? Interesting. I is less than k, and you're saying nums of k is I, right? Uh, if I is less than k, right, can we find out hmm, what if you do nums of I and nums of k? Nums of I and nums of k, x and I, right? um, if we just do nums of I, which is x, right, is x. So assuming when you talk about x, you can't just say number of I will be less than number of k. But if you're looking at x and k, when we say x and I, no, we can't really say anything about it. So, so here we are saying we require k when we require when nums of k equal to nums of k, and nums of k equal to I, and nums of k equal to nums of I, which is x, right? So we need to look at all the values and see who has the value k equal to I, is it? Like in this example, for example, we say 0 to 1, so 0. Once we say num of 0 is num of 0, right? So in this case, interestingly, num of I equal to I. What if num of I equal to I? I think you don't have to worry about it because num of 0 was 0 and the new value is also 0, and if someone wants it they can just take it from anywhere. Like for example, um, so if num of I equal to I, right, for example, in this case 0th value is 0, right, num of I equal to I, then we say that x is I cases, right? We say x is I, x is equal to I. So then we just put num of k equal to I. And in this case, you actually say num of I is I for num of I is y, then y is this. Num of I is I, num of I is again I, right? So we're saying y is equal to I, x equal to y equal to I, and if anyone needs x, so num of nums, sorry, actually it's not num, it's nums. So I should start using nums, right? So nums of num of k is I. What is num of k is I? So nums of k is equal to I means k equal to I. It's possible because no one else has if because only one person can have the value like in the initial thing, right? In the output. So yeah, I should just start using it. It's easier to understand. Right? So if nums of y is this, right? The answer basically input is nums. Um, so then it is so if nums of k is equal to I, and we say nums of I is I and x equal to I, then it means x is equal because I is I. When we say nums of k equal to I, there can't be two separate indexes that have the value I because it is a combination in only one place. So it means k equal to I, then x equal to x equal to uh, x equal to I equal to x equal to k equal to I, right? All the three are equal. So if nums of I is I, then you can just go ahead and write it. So it won't be used anywhere in the picture, right? What if nums of so this case is actually we're saying nums of one is two, right? And no of two is one. So one will get written here. So let's look at it, right? Take this. Now we say answer of 0 is equal to nums of 0, nums of 0, right? So we need nums of 0 is 0, nums of 0 is 0. Okay? Answer 1 is nums of 1. What is nums of 1? It's 2. Okay? Number 2 is 1. Now, if you write over here in the input itself that this is 1, we lose 2. Who needs 2? 2. So someone who will need 2 is someone who needs nums of 1. Who needs 2? Who needs nums of 1? If so, they need nums of 1 if they need nums of 1 if answer of y is equal to nums of y, where nums of y equal to 1. So then answer of y equals nums of 1, which equals 2, right? So what is this y? Let's look at it, right? So nums of y is 1. So for which nums of y is 1? So it's basically the index is index 0. This is 0, 1, 2, 3, 4, 5, right? So for the index 2, right, we'll actually need this 2. The output is 2, yes. So for this index 2, where in nums of y is 1, then if nums of y is equal to 1, then y equal to what is y? Nums of y equal to 1. This is the nums, no? So then y equal to 2. Y equal to 2. So when you say answer of right answer of 2, which is equal to nums of 2, which is num of 2 is 1, which is equal to 2. Right? Here we just have to swap these two. Right? So if you see, you just have to swap. So 1, 2, right? Finally, this 1, 2 came here. How does 3 work? Right? We look at that. Let's say you are gonna, so now you actually say this one, you actually over it with 2, right? Who will need 1? ANS of 2 equal to 1. ANS of 2 equal to 1. Who will need it? Who needs, because you will write it off, right? It's a who needs ANS of 2. Who needs, basically, who needs nums, right? Num of uh, 1. No, so who needs nums of 2? Nums of 2 is 1. Who needs 1? Who needs nums of 2? Someone who needs nums of 2 is answer of z equal to nums of z. Uh, they will need nums of 2 if where nums of z is equal to 2. Then answer z is equal to nums of 2, which is equal to 1. So now saying who will need this. So for what numbers of z is, for what z is nums 2, for what index is nums 2. For the index 2, it's 2, right? So for the index 2, we'll actually say nums of 2 is what? Hmm. So you don't need it beyond this. You need this one, this here. Who needs one? No one needs one after this, right? If the value of this is bigger, is it like that? Is it like that? Value is smaller, then you leave it later. Value is bigger, this is never made. It is small. Let's say these two values are, this is less than this, right? I wonder how it works. Let's see. Hmm. We have to look at the relationship between these also. If we say I is equal to x, then do this. If we say I is greater than x, then what can we tell about the other stuff? I is greater than x, then can we say anything about k value? Yeah, I is less than k, but it's greater than x, so x is less than k, right? Like those kind of stuff. So That way we will tell better because why it's tricky. Hmm. If nums of I is I, basically I and X are same. So you need to look at if I and X are same, the relationship between I and X. It can be only these. I is equal to X or I is less than X or I is greater than X. Right? Now, you're taking values only for I less than K because once we write I, we can't write to nums of I, as in, yeah, basically answer of I. We can't use answer of I where we need. So, if we say this, if I equal to X, then X is less than K, right? If I and X are the same, then let's look at our scenario and I less than K fact is I less than K, assuming, or we'll say, we'll make it a fact if you want, maybe. We'll say nums of I is X and nums of K is I, right? So, so I is equal to X, so nums of I is X, nums of K is I, um, and when you do answer of, I, you want answer of, I mean, nums of I is X, then nums of X is Y, right? You say nums of X is Y, assuming this nums of this is this, nums of X is Y, and nums of K is, right? So you are assuming these are the things, right? Nums of I is X, nums of X is Y, right? If you say I is equal to X, right? So you say I is equal to X. So then nums of I equal to X. If I equal to X, then nums of I equal to X becomes nums of I equal to I or nums of X equal to X, right? Um, so, and you're saying nums of I equal to I, that's all. Or nums, and both I and X are same, so you can either change this to X or you can change this to I. So this, so nums of 2, is it 2? No, it's 1 here. I mean, nums of, in this case, yes, I mean, this is the input. If I and X are the same, then you say is equal to some value. If both of these are same, what can you tell about X? What can you tell about X, Y, and K, right? Then and I is less than k, then x is less than k, right? And x is less than k because because I is less than k and x equal I equal x, right? X is less than k and it's equal x is less than k and cannot tell anything else. This is 0. Num of 0 is 0, so this is this. I get the expected output as this only. So k, let's say there can never be a okay, right. So if we're saying I is equal to x, and by the way, if I equal to x, then nums of let's not exactly uh, so if I equal to x, these two are equal. You say nums of I is equal to num of I is an index x, y, x. These are values, and this is also an index. Uh, this index is coming here, that's fine. I is less than k, okay. X is less than k, okay. And we are saying that is equal to x. Nums of I is equal to we're saying I equal to x and num of I is also equal to x. This is also equal. This is I is x and num of I is also x. That's the thing. So then we're saying this is x. Yeah, you're saying these two are the same and it's equal to I. Right, you're saying it's equal to I. So this are all the same. Hmm. Does it tell anything about k and y? So we know nums of k equal to I. We say nums of k is equal to I if and I equal to x, then nums of k equal to x, right? If nums of k equal to x and nums of I equal to x, then p equal to I. So let p equal to I and both are equal and num of I equal to x, then num of x is again I. Num of x is num of x is 1. No. Now x you don't know. Now x is actually num of I because x is equal to I. You're learning. Also, nums of x is equal to, you don't need nums of x, but let's just say you put this value and you do nums of x is equal to y if and I equal to x, then nums of I is equal to y, right? If nums of I is equal to y, the num of y you can't review. In this we got it's a mess now. Hmm. I think we need to look at it from like better perspective where there are assumptions and validations and whatnot. Maybe let me look at the next one to see if I can actually find something. If you see here, it's 0, 1, 2, 4, 5, 5, it's less than 1, it's greater. So 5 comes minus 0. 0, 1, 2. This one, if you see, it's actually just putting this 4 in front of this. So nums of 0, nums of 0. So nums of 0 is 5, and nums of 5 is 4. So you just put 4, and you lose the 5 though. And what gives so nums of 0, right? Nums of 0, so nums of 0 was 5 actually. Um, and nums of 5 is 4, no, this is 1 actually. Nums of 1, so nums of 1 0, and nums of 0 is 5 up there. Hmm. You need to basically look at 5. They're going to write to this. So who needs nums of 0? Someone who needs nums of 0 is someone who makes nums of y equal to nums of y, and nums of y is 0. Go here, find out what is the value of, should you do a sort of like a stack or a recursive call. Like next you look at 0, nums of 1. So we're going to change it to nums of 1 is going to be 0, and nums of 0, you need the value of that. 5, change this. Who needs nums of 1? Someone who needs, someone who has the old value of this value. Just keep going on. Hmm. Let's see if we can actually find a better way to put this. These are the only possibilities that I can think of. So it's I equal to x, which means the index and the value are the same. Then there is some, you know, this some k which is greater. Then you say x is less than k. you can say that right, where I is less than 2 and x is less than 2, right? Because I am equal, so x is less than 2. You can say that, and if these two are equal, as we put I here, or you can put an x here, all of that. And we're saying nums of k is x, or maybe I, whatever it is, right? And you're saying nums of k. Okay, interesting. So if nums of x is equal to y, no. Uh, Not num, also if nums of x equal to, actually, I mean, oops. Um, so let's say nums of I equal the answer of I is equal to, so let's just look at that. Nums of k is I, nums of k is x. So you're saying nums of k is equal to I and k, x are the same, nums of k is equal to x. Nums of k is equal to x, and you're saying nums of I is equal to x. There can't be two different indexes, as I and k can't be different. Then that would mean there are two x's, two x values, which is not possible, as all values in nums are distinct. So I is equal to x, so k equal to I, so let's say I k. So if k equal to I is equal to x, that's all. So if none more, so you can just say that, right? Because if k and I are the same, then you're saying num of I is x. The num of I is num of if num of x, num of x is y, and I is equal to x. Nums of I equal to y, right? Makes sense. Or if I equal to k equal, then I equal to x equal to k. These are all the same, I, x, k. And we're saying nums of I is equal to nums of x is equal to nums of I. This is equal to I actually, which we actually spoke about before. Um, I mean this, and we are also saying that it is equal to nums of x. And we're saying look at answer of I and k. nums of I is equal to nums of x because nums of I is x. Nums of x is equal to y and nums of x is equal to, so you can just nums of x is equal to nums of y. So you can just see that then nums of I is equal to nums of x is equal to y, then nums of I equal to y. Also, answer of I is equal to y. So nums of I equal to answer of I. Yeah. So if we say I and x are the same, when we say y and we say I is less than k, we still figure out that I, x and k are equal, and if nums of I is y, also answer is, so nums of I equal to answer of y equal to y, and we also know that nums of I, also nums of I equal to x, which is equal to I, which is equal to answer of I. Answer of I is x, and nums of I is equal to answer of I. Nums of answer of I equal to x. Answer of I equal to x, then x equal to y. So nums of x is y, I equals nums of I is y. So if nums of x basically is y, as answer of x is y, right? Nums of x is not y, its answer of x is y, right? Answer of x is y, and I, so answer of I is equal to answer of, no, answer of I is y, and answer of x equal to y, right? Do we need answer of x? No, I don't think so. We don't need this. So we'll just stick with this. So then I equal to x equal to k equal to y, right? So all of these are equal if I and x are, if I and x are equal and I is less than k, right? Looking at that, because we are traversing from left to right and we don't want to lose nums of I because it's going to get what do you say? I mean, nums of I equal to nums of I. So nums of I is gone, so you don't want it to be gone. So you try to see, do you need it for k, right? For any k after I. So what if I is less than x? For the same thing, I want to see if what if I is less than x? If I is less than x, then look at our scenario. Let's look at our scenarios. Um, scenario, scenario one scenario. Assuming nums of I is equal to x, nums of x is equal to y, answer of I equal to y equal to nums of I. This is equal nums of I is x, nums of x equal to y. Right? This I want to write it on the top so that it's clear. E nums of x equals this. Answer of I is equal to this. Right? So now you say so nums of A equal to I. Now how do you say that? Nums of A equal to I? Now that's an extra assumption. If these two are I, then oh yeah. I mean, num of K is equal to I because you think that you need answer of uh, K and you are looking for nums of K and you're losing the value of X basically because um, don't want to lose the value X if it's needed later for index K of nonce. So for example, that is uh, answer of K equal to answer of nums of K and nums of K is I nums of answer of K equal to this as nums of K is equal to I. Then answer of K is equal to nums of I, which is X. Right? We don't want to lose an value, so answer of K is X. So if that is the case, you don't want to lose it. So what are you going to try to do that for that? So now, so nums of K is I, and so I is less than X. So if I is less than X, right, and I is less than K, I is less than X, I is less than K. Okay. What else can we talk about these? I is less than X and I is less than K. Can't really say anything. Hmm. This is turning out to be a tricky problem if you're going to use the same input. We might have to jump around to see what maps to what. So if we're going to go for this, we're going to before putting y over here in this value, we look for which k value says I. If these two are equal, then all of these are equal and you don't have to worry. If I and x are equal, you're fine. right? You just can deal with it very easily. You can just go ahead and I and k are equal. This is going to be I, k, so that's the same thing. And x and I are all equal. So this is going to say answer of I is equal to mm, answer of or nums of this is equal to nums of what is nums of I? Nums of I is basically nums of I is x, right? And is x answer of I equals this as nums of I equals x, and then since answer of I is equal to nums of I again as I equal to x, right? Um, and answer of I equal to x as nums of I equals x. Answer of I equals I as nums of as I equals x. So all of this, right? You can also say something like answer of x is equal to x um, as I equal to x, right? So take up, but you don't really need x, you just need I. Answer of I, and so y and all is all x only. The same value. So if I and x are equal, the index and the value are equal, just can go ahead and say that um, it's equal to the index itself, whatever you want to put, right? But if the index is less than the value, for example, in this case, index is 0, it's less than this. You need to move. What about uh, index is greater here? What do you do? Right? Hmm. So I is less than x. Now I is equal to x. And so I is equal to 0. And then I'm going to the numbers of 3 equal. This is then it's a derivation. Then answer of this is this. Right? This this then this. So don't lose the value x if it's needed later for an x k of answer of I. So that is if it's needed later, right? So let's just assume it's needed later. So answer of k is equal to nums of k. Answer of k is equal to uh, uh, nums of I because nums of k is equal to I, and nums of k is equal to I. So anyone who needs nums of I is x. So anyone who needs to put x here has to count. So nums of I equal to nums of I. So nums of I, let's say, is x. Nums of x is y. You put that. Later, we need this x. Who will need the x? Someone whose nums of k. So nums of k is, let's say, I and nuns are high is X, then they come back. So it's like a chain here. So if you have this chain, you have to need it. Okay. I is less than Q, and we're saying I is less than X. Hmm. Is there going to be any other K which has I? No. So what can you tell about X over here? The I is less than X, I is less than K. It's kind of like a tricky thing. I think I'll spend some more time on thinking about this and then get back. That's all I had for this video. I'll see you next one. Bye.